Thank you.
Hello. Good afternoon, everyone. Thank you, Session Chair. My name is Manish Burgal, and I am here to present the paper on deep learning-based seed quality tester. Now, with the permission of Session Chair, I would like to start my presentation. Problem statement: in the seed packaging industries, the use of the traditional seed packaging techniques results in poor quality seeds in package and waste of huge amount of fine quality seeds. Like by the manual labor forces, it results in these kinds of problems. And in the commercial seed cultivations, where it is to be cultivated tons and tons of seeds, it is very inconvenient to perform the hand picking and winnowing technique in these sectors. So to overcome this problem, we have come up with a solution by, instead of filtering the seed individually, we can filter out in a cluster. Like we place the seed in a clusters of 100 and 200 of seeds, and we take the image of that cluster, and our system uses the deep learning model to classify the cluster into 5 categories, like excellent quality, good quality, average quality, bad and worst quality. And the excellent quality and the good quality clusters can be accepted to cultivation and packaging, and the bad quality and worst quality clusters can be straight away rejected. Now, as I talked about the deep learning, it is a part of a machine learning, and it is again a part of an entire globe artificial intelligence. More specifically, we have used a technique of convolutional neural network, CNN, which is a part of a deep learning. Talking about the methodology, we have condensed the methodology in 3 sections. First of all, data set preparations. We prepare the data sets by clicking the images, high quality images of 3,000 images of maize seed clusters, and we label the clusters as per the percentage of fine seed in the clusters. So if it contains the 100% fine quality seeds, then we label it as excellent quality clusters, and so on. Here are some pictures of the different clusters that we have created: excellent, good, average, bad and worst quality clusters. Now the important part of our system is building of the convolutional neural network. It comes up with the 4 different layers. First of all, convolution layer. As we can see in the slide, there is the input image. Convolution layer uses the mathematical convolution function, which is the multiplication of different values and final summation of all those values. As we can see, there is a feature detector. This feature detector rolls over the image and extracts the dominating distinguishing features from that image. So finally, it rolls all over the images, and here we can see this feature detector rolls over all of the images and extracts the features. Here this values 4, 2, 2. These are some features that describes the picture belonging to certain category. Here then finally we obtain a feature map. After we obtain a feature map, the maximum features, that is the distinguishing feature of that category, should be pulled out. It should be extracted, which is done by the max pool layer. Here we can see in the pool feature map 4, 2, these 2 values are preserved, and all the zeros are excluded because they do not point out to any kind of features. So after this layer, we have the flattened layer, which converts the pool feature map to the one-dimensional vector, which will be fed into the fully connected layer. Here we can see the fully connected layer, all the different nodes are fully connected, and the single one-dimensional vector, which contains the distinguishing feature of certain category, is fed into this network. And finally, we obtain a certain probability. We have used the softmax function. As we have multiple classes, we have used the softmax function to calculate the predicted probability. And as here we can see, dog and cat, this is the 2 binary classification. But in our multiple classification, we have used the softmax function to calculate the predicted probability of the category. Now the back propagation and CNN training, it is a very much important part in our system. The back propagation, as there is one-dimensional single vector containing the features, is propagated forward. This is the forward propagation. There will be some kind of error. That error should be estimated and fed backward again. That is the back propagation. That back propagation, the error is used to update the weights of the feature detector. As I told in the first convolution layer, the weights and values in the feature detector are updated as per the estimated error. Again, the more features are extracted and the accuracy increases in this process. And after many iterations, finally we obtain a decent accuracy. Now we conducted a couple of experiments. First of all, we experimented with the number of hidden nodes, which is the part of our convolution neural network, and what comes the accuracy with this number of hidden nodes. We used the 64, 128, 256, 512 and 1024 hidden nodes. And we obtained a decent accuracy with these two nodes, and we decided to select the 512 nodes as it provided with us 81% of accuracy. And the second experiment we conducted with the dropout layer, which is also the very important parameter of our system. We conducted experiment with different values of the dropout layer, 0.1, 0.2. Finally, we got a very good accuracy with this 81% accuracy in the training set and 80% accuracy in the testing set. And we selected the dropout layer with a probability of 50%. And this proves we got the almost perfect fit. Finally, we obtained a decent predictive probability accuracy of the CNN model with a limited data set, as we had only 3,000 amount of data sets, but those data sets were of very high quality with high precision. And the hyperparameters are tuned properly with as per the requirement of our data set. As we required the more resolution, we tuned hyperparameters properly. And we also concluded that the dropout layer can be used to overcome the overfitting problem of the training and the testing set. So the dropout layer was effectively used, and we concluded that it could be the best measure to overcome the overfitting problem. And if the system can be, it is used in the seed packaging industries and commercial seed cultivation, this could bring automation, alleviating the traditional conventional methods. Feature detections we can implement in the wide variety of seeds, and also we can implement the object detection robots in these sectors for the future detections. And we can use the different criteria like temperature, humidity, and germinating nature of seed. It can be used for the research in the future detections. Here we have created a small animation about the future detection, how it can be used in the industry. There is the clusters that comes up in the first conveyor belt C1, and this is the seed quality detection camera, as this our paper suggests. Now this the cluster comes in the conveyor belt. This detects the quality of the cluster as excellent, good, average, bad, and worse. And the excellent and good quality clusters are taken to conveyor belt C2, and the bad quality cluster is taken to conveyor belt C3, where there is an object detection robot R1, which filters out the fine quality seed from the bad quality clusters. And the good and excellent quality clusters are taken to conveyor belt C3, where there is an object detection robot R2, which detects and filters out the bad quality seed and foreign elements, damaged seed and foreign elements from these clusters. And finally, we will get a fully separated fine quality seed and this damaged seed and foreign elements, which will be the very effective without the waste of any fine quality seeds. Now here are the references that we have taken during our paper. 24 references. Thank you so much.
Thank you so much for your timely presentation. So I'd like to request audience if they have any questions, please.
ग्राभिटी सेपरेसन अथवा अरू कुनै मेकानिकल वेबाट गर्नुभन्दा यो कसरी पृथक छ अथवा इफेक्टिभ छ?
मैले बुझिनँ के भन्नुहुन्छ?
मेकानिकल वे हुन्छ नि ग्राभिटी सेपरेसन, अहिले गाउँघरमा युजली युज भइरहेको नेपालको कन्टेक्समा, त्यो भन्दा यो कतिको इफेक्टिभ छ अथवा यसलाई इम्प्लिमेन्ट गर्दा कसरी?
ग्राभिटी सेपरेसन मैले अब त्यस्तो मजाले चाहिँ थाहा छैन, त्यो अटोमेटिक सिस्टम हो कि म्यानुअल सिस्टम हो?
त्यो म्यानुअल पनि गर्नुहुन्छ?
ओके हो, त्यो होइन, म्यानुअल हाम्रो मेन कन्सेप्ट भनेको चाहिँ म्यानुअल चाहिँ केही पनि युज नहोस्, कम्प्लिट अटोमेसन चाहिँ ल्याउन सकौँ भन्ने हो। त्यही भएर एउटा
अटोमेटिक पनि हुन्छ।
हजुर, फ्युचर डिरेक्सन सोचेर गरेर हो। अब आई डोन्ट नो ग्राभिटी सेपरेसन अब त्यस्तो मजाले थाहा छैन मलाई होइन। यस केसमा अब हामीले चाहिँ अब इन्डस्ट्रीमा चाहिँ कसरी यसलाई इम्प्लिमेन्ट गर्न सकिन्छ अब्जेक्ट डिटेक्सन रोबोट युज गरेर, वेयर म्यानुअल लेबर फोर्स विल नट बी युज। सो कम्प्लिट अटोमेसन ल्याउन चाहिँ हामीले एउटा एप्रोच लिएर आएको। थ्याङ्क यू फर यर क्वेसन।
Thank you. Any other questions, please?
सिट्स चाहिँ राम्रो गुड ब्याड भन्ने कि बेसिसमा चाहिँ रोबोटलाई त्यो मेकानिजम दिया हुन्छ उसले सिलेक्ट गर्ने कि, जस्तै सिट्स हुन्छ नि होइन, रङलाई चाहिँ कसरी डिटेक्ट गर्ने, कुन बेसिसमा डिटेक्ट गर्ने भन्ने कन्सेप्ट छ।
हजुर, त्यो त अब हामीले फ्युचर डिरेक्सनमा राखेको छौँ होइन। अब्जेक्ट डिटेक्सन गर्ने त फ्युचर डिरेक्सनमा हो। अब फाइन क्वालिटी सिडहरूको डेटा सेट छुट्टै बोलाउने, ड्यामेज सिड अब जेनरली अब इन्डस्ट्रीमा आउँदाखेरि पनि त अब स्याकहरूमा ठुल्ठुलो स्याकमा सिड्सहरू आउँछ, त्यही अनुसार उनीहरूले फिल्टर गरेर प्याक गर्ने गर्छ नि त। अब त्यहाँबाट गर्दाखेरि त्यहाँ आउने जुन ड्यामेज सिड हुन्छ, फरेन एलिमेन्टहरू हुन्छ, फरेन एलिमेन्ट मगेको घोगो हुनसक्छ होइन फर इक्जाम्पल। अब त्यो सबै तिनीहरूलाई पनि डेटा सेटमा ट्रेन गर्ने अनि त्यसलाई चाहिँ रिजेक्ट गर्ने भनेर त्यही अनुसारले चाहिँ अब्जेक्ट डिटेक्सन रोबोटलाई त्यही अनुसारले ट्रेनिङ गराउन सकिन्छ। Thank you for your question.
Thank you. So, anyone last question? All right, Manish, so you already have questions from the audience. So, thank you very much for your presentation. Let's give him a big hand. Thank you, sir. Thank you so much.